Unit 3, Day 2. We're going to solve rational inequalities. All right, a lot of words there. Let's start with the middle word this time. Rational. Ratio. Fractions. Inequalities. We'll worry about solve in a minute. What's inequalities? You remember what symbols and what that involves?
Less than equals.
Yeah, the less than and greater than and less than or equal to, greater than or equal to, all that stuff. Open circles and closed circles. Shading, left and right, above and below, all that stuff is inequalities. And solve means, as opposed to simplify, I don't want to say equal because they're not equations, they're solving inequalities. So we're probably going to end up with intervals, like interval notation. Now let's start, let's actually back up a second and let's solve polynomial inequalities. And we'll do two of these meaning polynomial, and then we'll switch over and do two rational inequalities. Let's list some steps first. Kind of guide our process here. Steps. Let's find the zeros. Right, that was that whole last test, finding zeros by either synthetic dividing or by factoring or quadratic formula. Most of the ones today, in fact all the ones today, are going to be factoring because those are the quicker, easier way to go. So find the zeros, usually by factoring. Step 2, we'll put the zeros on a number line. And then we'll test the intervals. And that'll probably make more sense once we set up a number line. But once we put zeros on the number line, then we'll have intervals to test to see if they work or not. All right, let's work a problem here. X cubed minus 6x squared minus 7x is less than or equal to 0. X times, we're going to do it all at once here. Factor out. So we're going to factor that x out on the fly and then factor what's left. I think that's doable for this one. X minus 7, and x plus 1. You okay with that? Two-step factoring there. Then we'll set each of those equal to 0. We can't just set them like, we can't say x is less than or equal to 0, x minus 7 less than or equal to 0. That only works with equals, not inequalities. But there's something about x equals 0, x equals 7, and x equals negative 1. So we found the zeros, put them on the number line. And this may seem dumb to even have to say this, but please put them on the number line in order, right? Smallest to biggest. Like, people get really confused if you will get really confused if you put them on out of order. So the smallest one is negative 1, then 0, and then 7. And I'm not really worried about, my scale's off, so it should be, we're not really worried about the scale. This is just to help us visualize the answer. All right. at those places, are those going to be open circles or closed circles? Why closed? It's equal to, so we want to have closed circles. Step 3 was test the intervals. So I'm going to pick a number on each interval. So I need something less than -1, something between 0 and -1, something between 0 and 7, something more than 7. Because I'm trying to figure out where to shade. I'm trying to figure out, like, I know those are exact, but what about in between there? Are we good or are we not good? So I'm going to plug those in, preferably to the factored form, because that makes things a little bit easier. So -2 times -9 times -1. That's a lot of negative signs. Is that less than 0? I don't care about the number, I just care about the signs. 3 negatives make a negative. So yes, that one's true. So I will shade there. That works. Should space these out better. If I plug in -0.5, so I get -0.5 times -7.5 times a +0.5. Pardon my sloppiness here. The values don't really matter. Is it positive or negative? Negative times positive is positive. So is a positive number less than 0? No. So I will not shade there. Let's plug in 1. Let's go a little bit faster. Since I'm only concerned about positives and negatives, if I plug in 1, I get a positive times a negative times a positive. Everybody okay with that? I breezed through that one because I don't care about the numbers. I care about the signs. That would be a negative. Is a negative less than 0? Yes. So we'll shade there. And then if I check 8, again, all I care about is the positive, negative stuff. So positive, 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 less than 0. No, that doesn't make sense. So now I read off my answer. -infinity to -1. Union with 0 to 7. Brackets, because we want to include the endpoints, as opposed to parentheses for open circles. Let's skip an example and go straight to rational inequalities. Because the steps are the same, except it's a little bit different because now we have a top and a bottom. So 3x minus 7 over 2x plus 6 is greater than or equal to 0. So let's see here. I need the zeros of the top and zeros of the bottom. So zeros of the top. X equals 7/3. Zeros of the bottom. X x plus 6 equals 0. So x equals negative 3. Put those on a number line. Again, with fractions, negatives, be careful. Make sure the smaller number is on the left. This one should be easy because one's negative and one's positive. So even if you weren't sure about exactly what 7/3 is, hopefully you're pretty convinced that negative 3 is smaller than 7/3. All right, open or close circles? Yeah, that was a trick question. Cruel of me. So I'll say this one is closed. 7/3 is closed. Any reason why negative 3 would not be closed? Came from the denominator. What number can you not divide by? 0. If x is negative 3, that's a 0 of the bottom. Bottom zeros are always open. You want to make a note of that to yourself. Because you can't divide by 0. So it doesn't matter. You're right that you usually look at whether you include the equal sign. Like you've been trained well, taught well, you remember well. It goes with the equal sign. Except that there's like this more powerful rule that you can't ever divide by 0. So if you're going to make the bottom 0, you can't include negative 3. It doesn't matter if this is equal to or not. So bottom zeros are always open. All right, how about a number less than negative 3? Negative 4. You can pick any number you like. You can pick negative 5,487, but usually we go with something easy. How about between negative 3 and 7/3? There's a great choice in there. 0. And then something bigger than 7/3? Careful. Bigger than 7/3. Not 1, not 2. 3. If you want to make sure, you say, well, I'm not sure about 3. Maybe that's close. We'll just go with 5. 3 would work, though. And we're checking if we're greater than 0. So if you plug in negative 4, I'm going to get negative 12 minus 7 is negative 19. And in the bottom, I'm going to get negative 8 plus 6 is negative 2. Is that greater than 0? Yeah, again, I don't really care about the numbers. I'm worried about the positives and negatives. Positive greater than 0, yes, that is true. So plug in 0. Oh, this is an easy one to check because it wipes out the x's. So you get negative 7, 6. Greater than 0? No. Plug in 5. 15 minus 7 is 8. 10 plus 6 is 16. 8/16 is greater than 0, so that one works. And then I read my number line left to write off the solutions. So it starts at negative infinity, goes to, whoops, not 0. I was looking at the O. Negative infinity to negative 3. Parentheses on the negative 3 because it was an open circle. Union with 7/3 to infinity. What about the symbol on the 7/3? Bracket. Because of the equal to sign. Find the zeros, put them on the number line, test the intervals. Let's do one more. Let's see. Which one of those looks worse or better?
Is there always going to be a 0 there? Like less than 0?
That's exactly the one we want to do. Great question, Jason. Is there always going to be a 0 there? That is exactly what I want to work this one. Because there's not a 0 there on that one. What can we do to make there be a 0 there? Yeah, move it over. So your question was, his question was, is there always going to be a 0 there? And the answer is no, but there needs to be, so you make there be. So let's move it over. And now there's a 0 there.
Wait, when do you flip the sign? Or when you flip that, like the less than or...
When you divide by negative. I don't think you'll be doing that on this one, but there's some you could solve that way. Yeah, if you divide by negative, you flip the inequality. That rule still holds. Okay, I can't do this until I have one fraction. So back to Friday's lesson, adding and subtracting fractions. So I get a common denominator. 3x plus 3 minus 2x plus 4 all over x minus 2, x plus 1. So let's see, that would be x plus 7 over x minus 2 and x plus 1. I guess you could do this without writing them out, but I think it's helpful to write them out because it helps you get the open circle, closed circle thing right. So what are the zeros from the top? And the zeros from the bottom? 2 and negative 1. So the bottom have to be open circles always. How about the top for this one? Are those going to be open? Is negative 7 going to be open or closed? Closed. Because I don't care that it's equal to 0. Well, it's not in the bottom, so I go by the equal sign there. Let's make sure we put them on in the right order. Negative 7. And again, the scale doesn't really matter. What matters more, really, is that you space them out so that you have room to show your work. So don't worry about, oh, let me put all the hash marks on and make it look pretty. You just need to put them on there in the right order, preferably spaced out, so that you can check the intervals. Oops, we said negative 7 was closed. Negative 1 and 2 were open.
So, where it could be open the top?
What's that?
Is there a way to the top?
That's a good question. Is there a way? How would zeros from the top be open zeros?
If it was just less than.
If it was just less than or greater than, if there wasn't an equal to sign there, then the top would be open.
And bottom is always.
The bottom's always open.
So if there wasn't an equal to sign under it, there could be open.
Yes. So the top goes with the equal to or not. The bottom is just always open. What's the number between negative 1 and negative 7 that you'd like to check? Negative 2. Negative 1 and 2? 0. Definitely 0. And greater than 2? 3. Again, if you want to be creative or cute and you want to pick 700, why is a good question. Although it does make the math easy when you're only worried about signs. So if I plug in negative 8, I get negative over negative negative. Right? Negative 8 plus 7 is negative 1. Negative 8 minus 2 is negative. Negative 8 plus 1 is negative. So what happens with 3 negatives? Negative. Negative number greater than 0, because this is a greater than problem. No, negative number is not greater than 0, so that's a no. If I plug in negative 2, let's see, I get a positive over negative negative. So that would be positive greater than 0. That's a yes. Yes? I'm plugging into -2 minus 2.
Oh, it's -2. I thought it was positive.
It's all right. Plug in 0, I get 0 plus 7 is positive, 0 minus 2 is negative, 0 plus 1 is positive. And again, show enough work that I can tell what you're doing and that you don't get lost, but you don't have to write out everything. So negative greater than 0, that's a no. Now, we've only done 3 of these, but if you look back at the patterns that you think might have emerged, do you want to take a guess on whether 3 will work or not?
Yes.
Why do you think it will work? What's that? Because you did it. It does work. What pattern do you see from all of the ones we've done so far? They alternate. So, hold on. -7 to -1, and then we'll talk about that alternating rule thing. 2 to infinity. Careful with parentheses and brackets. You're on worksheet 2 now. But here's the alternating rule. They do alternate. The exception to the alternating rule is if it doesn't alternate. But what makes it not alternate is if there's a bounce on the graph. What makes a bounce?
0.
A double root. So if there's a double root, it won't bounce. The safest thing to do is to check every interval and not worry about it. The I'm going to push the limits thing to do is to check one interval and alternate off of that. Probably the intermediate thing to do is check a couple of them, make sure you're alternating, and then alternate from there and be okay. Unless there's a double root, and then you should probably just check them all to be safe. Because it won't alternate across the double root. Jason.
So what if you can't factor that? So like for number 3 in the worksheet, unless I'm missing, like, I guess I could square root.
Number 3 on the worksheet?
Yeah.
Number 3 on the worksheet. I'm glad you asked that. That will factor.
Square root?
No, you can't square root. You have to factor. X squared minus 9 and x squared minus 1. And I don't like that this is on the wrong side. So I'm going to say that all of this has to be bigger than 0 if I sort of read it backwards. So I'm going to switch it around like that. Oops, x minus 1 squared. Nope, x squared minus 1. I'll get it in a minute. And then both of those will factor. Now that's 4 zeros, which means 5 intervals, which is a lot of testing, but there's no double roots. So what is the picture going to look like? It's going to alternate. So you could get by with just testing 1 and alternating off of there. Again, I really suggest you maybe check 2, check that those alternate, and then alternate from there and be okay. But you really could check 1 and alternate after that. Good question. I'm glad you saw that before I hit stop.